Hello everyone, I think it's time to get started. So welcome very much to this live webinar about future logistics. My name is Per and I will be your presenter today. Some basic rules before we start. Please make sure that your microphones are muted. And if you have some questions, you are welcome to ask those in the end of the webinar because we have some minutes to answer questions. So let's start to go through the future within logistics. And first of all, of course, we need to describe what do we mean with logistics. And in its simplest form, logistics are pretty straightforward. It's very easy. It's about moving something from one point to another point, from A to B. That's what you're doing when you are doing logistic activities. But of course, we also have a lot of requirements to fulfill when it comes to the customers, because the customers, they are really demanding. So we don't just have to move from A to B. We need to also deliver the right amount of the parts. We need to deliver the right parts, of course. We want the parts to be in the right condition. They should be delivered to the correct place. And if you have a production line, it's very important that you deliver the parts in the correct sequence and of course also in the right time. So it's not only the transports, it's a lot of requirements that needs to be fulfilled when it comes to logistics. And of course, logistics has a really crucial impact on the complete supply chain. If we have efficient logistics, we will also have a efficient supply chain. And this picture shows a typical supply chain. So we start with the raw material, and from raw material, we move this to our suppliers. So they prepare a lot of parts for us, sub-assemblies, castings, weldments, and so on. So from the supplier, we move those parts to the factory, where we do more processing. We assemble it, we create the value to the customer, so we create the product that they want to buy. And from the factory, we send it out to our distribution centers, and from distribution, if we have a consumer product, we send it out to the retail stores. And finally, it ends up at the customers. So of course, in this supply chain, we have a lot of logistics. We have logistic inside each box here, inside the factory, inside the supplier, but we also have a lot of logistics between the different areas. So we have internal logistics, external, inbound, and outbound, and so on. And the final target is to meet the customer requirements for the customers that you can see down to the right on this slide. And the trend is that the customers, they get more and more demanding. They have really, really high requirements, both on deliverables, but also very high requirements when it comes to the products that they can buy. So they ask for more and more products. And of course, this adds a lot of complexity to our supply chain, and it adds a lot of challenges to our logistic activities. So if we look at the main trend at our customers, it looks like this. And we have used cars as one example, but I think you can take telephones, you can take shoes, you can take food or whatever. The trend that we see is that we have more and more product offers. So we have more products, we have more variants, and the customer is asking for more customization. So this is the trend that we see, and it's really clear within different type of products. And in addition to this, we can also see that the production volume for each product and for each variant is decreasing. Because even though we increase the number of variants, we will not increase the volume linear to this. This means that we will have a lower volume for each variant and product. And of course, this is a challenge. And if this were not enough, we also see that the life cycle for each product gets shorter and shorter. That means when you have prepared the factory for producing one variant, you know that it will be a shorter and shorter time until next time you have to change something. So this is a real challenge for all guys working with logistic development. And if we look at the plant, I think all of you recognize the main principle of this plant, but we can see that the challenges or the trend that we see from the customer requirements, that is very visible in our manufacturing plants. So first of all, we see that we have more and more parts in the warehouse. If we want to handle more products, if we want to assemble more products, we need more parts, and they are stored in the warehouse. We also see a trend that many products are assembled on the same line, or they are produced on the same line in order to handle flexibility. Because if you have all products together, you know that you can quickly change the volume in order to meet customer requirements. That means that you need a lot of parts to go into the same assembly line, and that results in a lack of space at the line side. So you want to store all the parts, but you don't have the space. So that is a big challenge in factories today. And one way of handling that is to prepare the material. So that's why we see a big trend that you have close to line kitting, for example, where you prepare a specific material for a specific product at a specific time. That is custom prepared and delivered just when it's needed, just before it will be added to the product. And of course, this way of supplying material requires that you do more and more frequent deliveries, because you need to deliver for each product, which means that the pace of logistics is much higher today than it was in the past. And of course, as I mentioned, we also have the frequent change. So maybe this setup works today, but we know that in 1 year and in 2 years, it will come new products, which will require that we have a flexible system in order to adapt the plant for the future needs. And we also see a big trend for forklift-free. So that is strategies that are implemented in a lot of plants. So customer requirements, a lot of different products, a lot of different variants in the plant or in the factory. This is the main challenges. And it's interesting to see that if we compare the footprint of a plant from the past until now, we see that there is research showing that more than 50% of the factory space is used for logistic activities. That can be storage, it can be kitting, it can be transportation and so on. But we see that more and more footprint is used for logistic activities. So this is something that we believe it will be even more footprint in the future. And then, of course, it's even more important to perform the logistic activities in a very efficient way. And in order to do this, of course, there are a lot of trends when it comes to logistics, and I would say all of them in some or another way aiming to do the logistic activities more efficient, and most of them are also connected to the fact that we have more and more parts and more variants. So logistic is a big part of the operations, and therefore we thought it was interesting to have a webinar about the trends, what will be the future of logistics. And you can do a lot of Googling on this, and you will find pretty much the same results. This shows the trend radar from DHL, a big logistic player, and it contains a lot of interesting things, and you can also look for other research institutes and so on. And as I said, it will end up with pretty much the same view. But this is based on input from research centers, it's based on input from customers, and it's also based on input from small companies and startups. So it's a pretty wide range of input into this trend radar. And it's divided in social and business trends, and then you have technology trends to the right. And in this webinar, I will focus on the technology trends. After this webinar, I will send out the link to the report so you can read it afterwards if you want to look more into the social and business trends. But right now, due to time restrictions, we will focus only on the technology trends. And this is some areas that we will talk about. We will look into self-driving vehicles. This is predicted to be the next game changer within intralogistics. And this is it's in the future, but it's happening a lot already now. So I will show you some examples in this webinar. We have the Internet of Things, also called Industry 4.0. We have the 3D printing. We have robotics and automation. We have unmanned aerial vehicles, and we have augmented reality. So this is some areas that we will talk a little bit more about. It's areas that definitely will be seen a lot in intralogistics in the future. So if we start with the self-driving vehicles, I'm sure that most of you have seen some of those examples. But it's pretty interesting to see how technology, how the evaluation and the development of technology can have such a big impact on a business, and then specifically navigation technology, electric engine technology, and so on. All together has really resulted in a big boom of self-navigating vehicles. So this is some examples showing the housekeepers that they can maneuver on their own in our homes. We have the automatic movers, so you don't need to cut your grass anymore. They can navigate on their own out on the yard. We have seen a huge and big trend of autonomous cars. The picture shows a Google car, but I would say all major car companies, they have more or less implemented features that makes cars self-driving. We have also Tesla, for example, that are in the forefront, that have a really high degree of self-driving capabilities. And we also see, for example, personal delivery robots, so they can deliver food, medicine, and so on to your home. And they are, of course, also navigating without any infrastructure. And all this technology together, or the technology that is used for consumer markets and so on, of course, that contributes to very mature technology. And we can see that this technology is now used in manufacturing plants. And as I said, it will be a game changer how we move material in our facilities. So this is one example from BMW. They use self-driving vehicles inside their plant. And they see it as a key enabler to really lower the cost. And as you can see in the text here, they have for a very long time focused on the assembly lines. And I think this is very common for a lot of plants, that you have spent a lot of time to make the assembly lines as efficient as possible. You look into the line balancing and you really try to make it as efficient as possible. And maybe sometimes you forget about the logistics. But in this case, it shows that BMW, they have really gained from this, because they expect to cut 5% per car annually. And that's a lot of cost. And it also shows that if you can improve logistics, it will have a big impact on the total product cost. And one thing with this technology is that from a flexibility standpoint, you don't need to install any infrastructure. So they build their own maps, and based on that, they will navigate in the plants. They are also very famous, they are popular to use in warehouses. So this is from Amazon fulfillment centers. They have 16 fulfillment centers, and in total about 30,000 robots. You can see the robot here, the orange stuff. And they are moving those shelves around to different pick stations, where you have people adding or loading different parts onto onto the shelves. And you can see here the trend of number of pickers and packers from 2007 and 2016. And I think it shows the trend that we saw in the beginning of the presentation, that we have more and more logistic, more parts, more customization, and so on. This can be seen in those figures. And of course, the reason behind start to use robots is to decrease the cost and to decrease the number of operators and so on in the warehouse. So I think we have reached a point where we will see a lot of more automation in our plants, because it's getting more flexible and more affordable. This is some more benefits with self-driving vehicles. Of course, compared to human, it can work 24/7, and as I said, the robots are getting more and more reliable. You need to spend less money both on the drivers but also on the actual forklifts, because AGVs or self-driving vehicles are more, it's a lower investment compared to forklifts. They are intelligent, so as I said, they can navigate on their own, they can avoid collisions, they can take decisions which route to take and so on. And they are flexible, so if you decide to change the plant, you change the way you present the material, you want to present the material with another face to the line and so on, it's easy to accommodate this, because the self-driving vehicles, they are not fixed to any route. And also safety is a big selling point for self-driving vehicles. We have some more bullets here to the right. It's quiet, and I think one important factor is that it's scalable. You can start with a few self-driving vehicles and prove the technology or implement the technology for your plant, and then you can scale it up just by implementing more robots. And as you know, FlexQube, we make modular carts, and we see more and more products coming up, and we also have a partnership with some of robot companies where we make the carts that holds the parts that are moved around. And that's a big benefit with the robots, that it's easy they can handle different carts in order to take care of different part numbers. This is some examples of FlexQube integrations. So to the left we have a cart with roller together with the tug robot, totally autonomous. And to the right we have another type of cart. It doesn't have a caster, so it's lifted up during transport of this robot. It shows two different ways of integrating with a small robot. We also have the tugger variant, and in this case maybe that is more suitable for long transportations. So we have robots that is self-navigating and that pulls a train of carts. So this is you can say it's a tow tractor, but it's autonomous, so you don't have a driver for it, and it can navigate and take decisions on its own. Next trend that we see is augmented reality, and this type of technology has been on the market for a while. One of the first glasses was the Google Glass. I've tried them myself, and they are pretty cool, and you can see instructions and so on. And nowadays it's more and more options available, and it's also more software and intelligence behind in order to prepare all the data that you need. So I think the main task for this kind of equipment is in the warehouse, in the picking process. You can have a description where to go, you can have a description where to pick, and so on. And in the left corner you can also see that you can have, if you are a forklift driver or a tugger train driver, you can use the glass for driving instructions like a navigation system. This shows how DHL are working with Google Glass, and you can see you utilize the camera in the glasses to pick, and you scan the trolley on the barcode, and then you will have the instructions where you find the parts and where you should pick them. You also have the instructions where on the cart to load them. And of course, this can also be used in assembly operations or in any environment where it's complex for the operators, where they have a lot of parts and a lot of instructions to follow. And the benefits with this technology is, of course, that it's very agile and a very quick way of doing fulfillment, and it should reduce the error rates because if you have clear instructions connected to the system, you should make sure from the beginning that you pick the correct parts. It's user friendly, and one big benefit is that you have your hands free. So if you work with logistics and you work with picking and so on, it's always a big benefit to have your hands free. Then we have the next thing, which is 3D printing, and that should be seen as like the main enabler for a batch size of 1. That was one trend on the business trend that I showed you in the beginning, but that is batch size 1. So it's forecasted that batch size 1 will really be the next big thing in the future. That is already in place today. When you buy a car, for example, it's custom made for you, but it's not that common when it comes to typically high volume products like shoes, for example. But we now have both Nike and Adidas. They have started what they call speed factories. That means that they do 3D printing of the shoes, which also enables that they can actually produce a batch size 1 of shoes. So a customer can order a really customized shoe just according to their own specification. So it's starting to be more and more implemented in like serial production. In the past, it was only used for prototyping, but as you can see here, it's getting more and more used in serial production. To the right, you can see the latest generation of jet engine from GE. So this is used in latest Airbus 320 and also the 737. And this contains of 20 3D printed parts. So in the series product, in the engines that are in series production, they are using 3D printed parts. So we see that this is coming, and there are some words out there says that, for example, Nike, that they predict that in 10 years they will only be an IT company, so they will print all their shoes. And there are also some studies showing that if we look at this from a logistic perspective, it will, or it could drastically reduce the need for both air and cargo shipping, because if you can succeed with 3D printing, that means that you can produce things really close to the customer or really close to the next step in the process. You don't need to ship from different regions of the world in order to achieve the lowest price. Then we have the Internet of Things, and it's also called Industry 4.0. So from a historical perspective, the first industrial revolution was the mechanization. That was when people started to use steam power, water power to start up the mechanization. That was a big revolution for the manufacturing industries. Then we have the second revolution. That was the mass production, the T4, where you have the labor of division, you create the assembly lines, and you have a really high pace in the manufacturing. So that was the second industrial revolution, the mass production. And then we have the third revolution. that's when we started to use robots, PLC programs and so on, to really boost the productivity and the efficiency. We made a lot of similar parts in the most efficient way. So it was really adapted for the mass production, but we made mass production in a more optimized way. And now it's a lot of talk about the fourth industrial revolution, which we then call Industry 4.0, or the Internet of Things. And that means that our plants, they will contain a lot of intelligent equipment, and all equipment that we have in the plant, like robots, AGVs, conveyors, or computers, or whatever, all equipment will be connected to the cloud, to the internet. And by having everything connected, we can store a lot of data, we can analyze, and we can, in a smart way, decide how to make things even better. And we can do this in real time. So, for example, a robot that moves material can take own decisions. Should I take this path, or should I take this path, for example? So this is some cyber physical systems, it's called. And this is something that more and more will be implemented gradually. But I found some slides showing a parallel to what's actually happening in our house, because it's exactly the same thing. We can see a lot of products for our own houses where we can connect those to the internet. So we can have the stereo connected, the alarms, the heating functions, the lamps, and so on. And it turns up applications where you can put all those intelligent systems together. So if you have an alarm, you can automatically start the lights, for example, or a sound, or the stereo. So it's a similar way of thinking, and we can see that it's already happening in our homes. Then we have another trend, which is robotics and automation. And as we see in the previous slide, it's not new. It was already in the 60s that we implemented robotics. And that was the third industrial revolution. But this is another type of robot that really comes strong. They are more intelligent, and they are sometimes also called cobots. And the meaning behind that is that they can work together with humans, so they don't need to be isolated in a cage. They can be side by side with people. So you can see a picture of this from a Ford assembly line, for example. You have one assembler, and then you have the robot, and they are doing a task together. And of course, this type of equipment will also be very useful in logistic operations. If you do a kitting, for example, of heavy parts, or you have a very repetitive task, the use of robots is, of course, it could be a huge, very good way to improve efficiency. So they are like they are equipped with cameras, and they have sensors, so they can feel pressure. So if they get in touch with a human or something else, it will right away take actions to avoid collisions and so on. And we see some areas of usage to the left. As I mentioned, we can do kitting, we can do a packaging, and we can do a loading and unloading, for example, of trucks or pallets or whatever. And I found some statistics, because sometimes you say that the robots is a threat. It will take a lot of job opportunities away, but it's actually the opposite. So this shows some statistics from a US automotive industry. So from 2010 to 2015, in total, they installed 135,000 industrial robots. But on the other hand, they employed during this period around 230,000 people. So they have employed more people than robots, because it drives a lot of other work tasks, and it improves productivity. This shows another example from Fetch Robotics, and this is also something that exists on the market today. Even if maybe it's not used everywhere, it's still a very strong trend coming, that you have the robot arms movable, so they are on a movable platform, and they are followed by a transporter. So in this case, you have a pick robot and you have a transport robot, and they don't need to work together all the time. So if you have a warehouse, for example, you might have more transport robots than you have pickers. That is totally depending on the mix and so on. But the general idea here is that you have the pick robots, they're working in a specific area. And then you have the transporting robot coming to this area with the information about, okay, I want this part on board. And it sends that signal to the pick robot, and then they will together make sure that they will load the correct part. So this is a replacement for humans when it comes to picking and kitting also. Next slide here shows the drones, and I looked into this technology maybe a couple of years ago, and I said this should be really interesting for intralogistic activities. I tried to find some examples, but I couldn't find it. But fortunately, now I could actually find a couple of different examples where you use drones inside assembly plants. So, but from the start, they were used, or the intention was to use them as a last mile delivery. So they could deliver a package to your home if you order a product that fits into the weight range for the robot or for the drone. It can deliver it all the way to your home. Of course, it's also used to transport parts to areas that is not reachable for normal vehicles, like offshore, or transport spare parts to ships, for example, or to other areas which is not possible to reach. And very interesting application is actually the intralogistic transportation, because if you use drones, you can use all 3 dimensions of the factory. Because nowadays you only use the floor level for transportation, and you have a lot of unused volume and area that actually could be utilized in a better way. So in that case, you could have the drones following predefined path in the plant to deliver in sequence, flying from the warehouse directly to the point of consumption on the assembly line. And of course, this would be a really huge game changer. So you can see here on the top, it's a vision picture. But if you do some research, you can also see that it's actually happening also in reality. So this shows from the future factory of Audi. They are transporting a steering wheel from the warehouse to the final assembly line. And of course, if you have a really high customization, so that every steering wheel is different buttons and so on, you need to deliver the steering wheel in sequence. And one way of doing that is to use the drone. So that was some industry trends. And I think the conclusion is that we have a lot of solutions and we have a lot of trends. And of course, we have the challenges, but it's all about to increase the flexibility in the material handling system. It's about being able to handle change. We want to move parts more and more frequent. We need to handle a lot of different parts, and it's getting more and more complex. So altogether, the aim is to have a more robust and a more flexible material handling system. And I will finalize this webinar with some words about the FlexQube concept, because the reason behind our concept is actually to handle change. So we don't sell a specific solution. We have a concept, and with this concept you can build different things in order to integrate with all those nice features or nice equipment that we actually saw in this trend radar. So whether you choose to go for an AGV or a tug train or whatever, you need something to carry your parts, and that's our basic idea, that we have a concept that can be adapted and rearranged when it's needed. So we have the different building blocks. We have the blue, which is the flex beam, we have the tube, we have the FlexQube, and the plate. So this is the 4 main building blocks, and together those can create a lot of different custom designs. This shows the design process. When you design a cart, you have the building blocks. Then you start with the platform, you go on with the casters and the tow bar. And in this phase, you really need to have a close integration with the movers and equipment. So if you choose to go for a self-driving vehicle, for example, it's really important input to the cart design process in order to fulfill this in the best way. And the choice of equipment for the future will also it will affect the factory layout. Do you want very narrow aisles, or do you want one-way aisles? And so on. It's a lot of decisions to take, and this will also affect the design of the cart, of course. And then we have the type of load that is mainly affecting where you want to have the handlebars. It also affects what type of top structure, for example, that you need. But if you are looking for a cart and you know that, okay, I want to use this type of equipment, I want to look for this type of integration, we are gathering all our solutions in the solutions library. So this is like the kids, they can go in and see what other kids have built with the Lego bricks, and this is for industrial engineers and logistic engineers. They can go in and see what other colleagues have created, and to really have some good inspiration. So if you decide that you need a cart, there are it's 2 different ways to do it. First, you can go through a design on demand session. That means that FlexQube will design the cart for you. And we have a very streamlined process for this. It's a little bit like a McDonald's approach, but from a cart perspective. So we start with the preparation. Before we have the meeting, you will be asked to do some preparations. What parts do you want to move? What is the weight? And so on. And then you have the meeting with one of our designers. And during this meeting, the cart is designed during a live session. So you will see how the cart is created step by step, because our designer is sharing the screen. So you can have a direct input. I want it like this, or I don't like this, and so on, in order to really fulfill the cart design. So after the meeting, when we have the main concept accomplished and the main requirements, it takes around a week and the design is fully completed. Then we prepare the quote, we prepare a lot of data sheets, pictures, and so on, so you have a good communication material internal to convince your colleagues that this is a good solution. And then we have prepare an offer with a quote, and then we have a purchase and delivery. And the beauty with the flexibility is that you can do this very pretty rough, and then you have something to evaluate in the plant. You can have all the input from assemblers, logistics, operators, and so on to evaluate, and then you can go through this process again. But I think it's important to say that you should really utilize the flexibility in the concept to have a frequent loop to really evaluate in practice, because that is much more powerful than spending a lot of time on the drawing board. If you want to design on your own, we have recently launched our CAD library for Onshape. So Onshape is it's the first CAD system that runs in your web browser. That means that it's available for everyone. and it's created. You don't need to have any installations. You don't need any licenses. You actually don't. The only thing you need is a web browser. And if you create an account, you can design with FlexQube building blocks, because they are all available in the cloud. And when you start to design different carts, the carts themselves will also be available in the cloud. So it will be very easy for you to share with your colleagues and so on. And different functions in the company might have different need for information, and they will always find this information in the cloud. I think we see today that when you have a plant, you have a lot of stakeholders. You have person A buying some carts, we have person B buying some carts, and we have person C buying some other carts, but it's not very synchronized every time, so it's hard to know what other people are buying. This could be one way of gathering all the data in the cloud to have it stored. So if there are someone that is interesting or know someone at your company that could be interested in doing their own designs in Onshape for FlexQube building blocks, you can get in contact with me or one of our design engineers, and we will schedule some training for you. So we are getting closer to the end of this webinar, but I wanted to show this picture because we have talked about the future today, the future trends. But this is not something that we are doing right now. We are all, FlexQube as a company, are always trying to keep up with industry and to really learn and see what is happening out there. So we do a lot of investigation for the industry trends, see what is the latest. We are paying a lot of attention to Industry 4.0, which I explained. We are also involved in a lot of forklift-free projects. So that is something that we can support a lot in with different cases and different ways of solving things. We are honored to have a lot of different customers. In this presentation, it was a lot from the automotive industry, but we also have customers within energy, within aviation, we have within the food industry and so on. And sometimes it can be good to see examples from a completely different type of business to open up the mindset a little bit. So we can also provide those kind of photos or brainstorm ideas. We try to learn project management, how is the best way to do changes in the plant. We look into lean production that has been on the market for a while, or I think everyone knows lean production. It's a common tool to find different type of waste in your plants. We work a lot of integration. For example, we have integration with still tugger trains. We are working on integration with self-driving vehicles, and we see this as a really key enabler. We want to offer our customers integration to whatever equipment they want. So if you are looking for some type of transportation equipment, we are open to look into different ways of doing the integration. And we will continue to do the webinars. It's a good way for us to share our knowledge. So we will continue having those webinars. We are doing some CTO letters, writing about industry trends and so on. And we try to participate in trade shows to keep up with the latest trends and the news within intralogistics. So that was everything for today. I hope it was valuable. So I will stay online for some more minutes if you have some questions. So I will stay online for some more minutes. Otherwise, I thank you very much and I wish you a good day. Okay, no questions, so we will close the meeting. Feel free to contact me after the meeting if you have any additional questions. Thank you very much. Bye-bye.